Alex, what led you to co-founding Wave in 2017? Was it your passion and love of surfing?
I called the company Wave because I wanted the chance to catch a wave home in the middle of a city like London, which sadly doesn't have any surf breaks. But no, look, I had the chance to do a PhD for many years, looking at the areas of how to build a more intelligent robot, how to solve the problems of computer vision to let us see the world for ourselves, understand what's around you, what's going to happen next. And that work led me to a pretty deep belief that we have the capability now to build intelligent machines that can make their own decisions, can understand the world for themselves. And at the time, 2017, the prevailing approach to autonomous driving was one that was centered around building strict maps and rules that told the car how to drive. And I think we all know where that's gone. It's cost billions of dollars. It's not clear how that's going to scale to be ubiquitous for everyone everywhere. And I thought there'd be a better way.
Is a bit away. Looking from an economic standpoint, rules-based you can't scale. You're doing an end-to-end neural net solution. You can scale out. What role did economics play when you were co-founding the company?
I think it's a super important consideration because like, I guess one approach is to throw all of the sensing, compute, and infrastructure on the vehicle to try and solve the problem. Everything from the kind of sensor stacks and compute stacks you see driving around San Francisco today. But interestingly, we were a startup with pretty lean resource as we were starting to grow, and I think that forced a lot of innovation. We didn't have the capital to just throw $200,000 worth of kit on the car. And so that was a good forcing function to look, okay, what can we get started with just cameras? How can we be more lean? How can we deal with the kind of level of compute that you find in production cars today? So that's where we started. And yes, we started with cameras, but a common misconception is that we think camera only is the way to go. Actually, I think the sensing stack you need to use should be based on safety, scalability, and economics. And I think that camera radar is a really viable strategy. You might choose LiDAR, but ultimately, whatever sensor package you choose, you have to make sure that it produces safe enough behavior and it has the economics to scale. And the fundamental approach that we're looking to take is to enable solutions at scale, enable solutions that don't require that level of infrastructural support, the ones that can produce something that is viable for people to experience everywhere.
Do you see 4D radar potentially fitting in that stack as the technology evolves and becomes better?
Well, what are the dimensions in 4D radar? I guess radar typically has 3D. You've got the various width and height angles as well as range, and then you have Doppler or the fourth dimension. And so a 4D imaging radar, absolutely. I think that we're seeing the movement away from radars that you buy that do the detections and give you the detections as output to feed into your perception stack. But really, those detections can carry a lot of noise. And the beauty of end to end learning is you can take the raw signal from either a camera or a radar or whatever sensor you're using, FMCW, LiDAR, or whatever's coming next. You can take that signal and learn from it directly. The beauty of that is you can learn when to trust the sensor, when not to, and get all of that from an unsupervised signal. Simply by predicting what's going to happen next, you can learn when the signal from a sensor is reliable and when you might need to rely on another redundant modality.
That leads to the breakthroughs in AI that we've had. You're based in London, DeepMind, and then the last year with ChatGPT. I'm going to quote something. You gave a really great presentation. I got to give Martin Briggs a great job for inviting you at the Bank of America's Transforming World 2023 event in London. I want to quote from your presentation. This is really impactful here. Self-driving is an AI problem that hasn't been the consensus view. In fact, it's been the contrarian view for many years. Everything has changed this year owing to ChatGPT. When we founded Wave, the thesis we had the rules and mapping-based approaches of the autonomous vehicles in operation today wouldn't let this tech scale. In order to bring it to everyone anywhere, you needed a system that has onboard intelligence to understand and make its own decisions. End quote. You're right. Did you see the ChatGPT moment before it happened, and that's why you created Wave?
Look, I think the ChatGPT moment has blown us all away in the AI field with the impact it's had, the consumer reach it's had. But I think it's also fair to say that we saw a lot of this progress coming through GPT-1 and 2 before GPT-3. But I think the thing that personally surprised and inspired me was just the sheer scale of engineering and sheer scale of engineering that OpenAI was able to achieve. The amount of RLHF, red teaming, feedback, and scale of compute that made a hundreds of billion parameter model possible. I think that was a remarkable achievement in itself. But also the fact that language is such an accessible, like chatbots are such an accessible thing that became so universally delightful to people. I really do hope that self-driving can be, in a similar way, the very first time that people across the world get to experience and be delighted by embodied AI. I think there's going to be tons of different applications of embodied AI in the future, but I think self-driving is going to be that first example, and I can't wait for a similar moment when people get to touch and experience what we are seeing the early stages of here at Wayve with embodied AI in your cars or the vehicles that drive you around.
Wave posted a great video. Mr. Bill Gates went and visited you in London, and the smile on his face was remarkable. And you said to him, "Where would you like to go?" "I like fish and chips." And your vehicle drove Mr. Gates to get fish and chips. Was that planned? The vehicle performed very well, but the point is there, the delight on Mr. Gates's face says it all.
He was in London for, I don't know, maybe 24 or 48 hours. And the one thing he wanted to do was go get fish and chips. We typically test with the vehicles around near our office in North London, or we do other trips to cities around the UK. At the time, we hadn't really done much testing down near Parliament or where his hotel was in central London. He told us he wanted to go get fish and chips. And so we did this route that we hadn't done before and showed him driving through central Soho, where it was filled with pedestrians and cyclists. It was a mind-blowing experience. And we got there, and I guess the security team didn't let him go into the fish and chip shop. So we ended up eating it in the back seat. What a cool experience.
The vehicle was never driven that route in central London. Mr. Gates' hotel was. He just picked him up, and then you went on your journey.
That's the whole thesis behind our approach, is to build a system that can learn behavior. For example, if you need to go through a traffic light, we don't want every single traffic light. We don't want to have to set the rules, tell how many lanes there are, where the traffic lights are, what to look for, which traffic light associates with each lane. The behavior 1.0 approach tends to map all of those things out. Instead, we want to build an AI that learns how to deal with a traffic light, learns that the kind of things that you and I take for granted when you go through a situation like that, so that when you go to a new one you've never seen before, you know how to deal with it. Now, the result is that we have a neural network that is capable of understanding driving scenarios in a general sense. We can take it to new cities we've never been to before, and it can drive on these routes without an HD map, without any experience from that city, because it's able to take that knowledge and apply it to new scenarios. In a similar way, we have been doing last mile grocery deliveries here in London with our partners, Asda, for about a year. And one day, Asda asked us to shift to another one of their sites in London. And in a space of literally a week, we were able to take our operations from one site and move to another and do deliveries to new people, new routes in a new situation, because we didn't need to pre-map it. And I think if we jump back to the economics question you're asking, I can't see a world where it is economically feasible, even with crowdsourcing, to produce and maintain an HD map at scale. So I think the way to bring, beyond a small affluent area like San Francisco, but the way to bring self-driving to scale has got to be through having the onboard intelligence. And of course, you need a navigation map, but having the intelligence to not require an HD map that tells you about the environment.
The technology's evolved, and we'll go down old technology row when self-driving first came out. Oh, you have to have VDEX, you have to connect everything. Nope, prove you didn't. Oh, you have to have an HD map, and then you're proving that wrong. The technology is evolving. As the technology evolves, it's becoming economically scalable. When it becomes economically scalable, you can make a profitable business. That's what a lot of the traditional researchers do not understand, all the breakthroughs that are happening in AI that are enabling this technology to scale. You call this AV 2.0. Is this achievable because you're end-to-end AI solution?
Yeah, that's the big distinction. If you look at so many challenging large data problems, take from computer vision, language, game playing agents, or now robotics, we've seen this trend of these problems fundamentally being, I wouldn't say, they're still not solved in some cases, but at least transformed through end-to-end learning by being data-driven and statistical and not relying on hand-coded representations. Like back in the day with language, you used to extract words, phrases, nouns, associations, and things like this, and then use those handcrafted features in a database to understand the meaning of language. And of course, ChatGPT and these large language models are all possible because of end-to-end learning. Now, we're seeing the same thing play out in robotics. Is moving from partial learning to end-to-end learning is what enables us to learn driving capabilities that are more complex than you can hand engineer. So that step to an end-to-end learning approach for autonomous driving is what we refer to as AV 2.0.
Is this the ChatGPT moment for autonomous vehicles?
I think it is.
It's going to scale. You mentioned you're doing delivery. Is that a class 6 type vehicle? What type of vehicle class is that?
We've been working with light commercial vans, 3.5 ton vans, as well as passenger vehicles today. And we've built a neural network that can drive both of these. I think it's really important that we get diverse data and are able. Well, one of the really interesting things is self-driving cars have typically needed to be trained through what you think of as on-policy data, where you actually drive the cars and you get their own experience to be able to learn. The unique thing about our approach is because it's unsupervised, because we can learn to just generally observe videos and understand the world, we can train on heterogeneous data from all kinds of vehicles with different sensor packages, different sensor layouts and architectures, as well as in different driving cultures. And ultimately, where we want to be is have a single neural network that learns from grocery delivery in London, ride hailing in Florida, I don't know, public transport in Stuttgart, wherever you are around the world. We want to have all of these different experiences and use them to train the most safe and performant driving AI that truly generalizes.
Is there a limitation of the type of vehicle that your technology will eventually be able to be ported or transformed to or expanded to?
I'd love to support and accelerate the electrification and make sure that we support electric vehicles first. But limitation, you need to have, what do you need for autonomy? On the vehicle, you need to be able to have a sensor architecture that is redundant and gives you the surround visibility you need to drive. Something like radar cameras, that visibility around the vehicle. You need compute that's sufficient to run a neural network. For example, we run on the kind of compute you see in vehicles today, whether it's Qualcomm or the NVIDIA Orin or on computes and beyond. So that kind of level of embedded compute. And then you need a reliable and resilient power source to be able to support that. And I guess most electric vehicles and some combustion engine vehicles have that. But those are the sort of basic requirements. But other than that, and of course, a controls interface, a drive-by-wire that has the redundant actuation that you need for safety. But aside from that, it's a pretty broad swath of most modern vehicles today that are coming out from all the major manufacturers are starting to have those requirements. And that's what's really exciting to us. I think that gives us the opportunity to get this AI, get this software deployed at scale to start getting experience and exposure to vehicles around the world.
You solved the original Mercedes-Benz R&D project. This was in the early days of self-driving. I went and visited Mercedes-Benz R&D facility in Sunnyvale in California. And it was really neat. It was an S500, and the gentleman who was the CEO at that time said, "Oh, open the trunk. I want to show you something." I opened it, and the trunk, as you could imagine, was full of compute. And he said, "We failed." I said, "Excuse me?" He goes, "We failed. Our customers, our number one request for an S500 customer, golf clubs. If the golf clubs can't fit in the trunk, we failed." And he kept pushing his team to make the compute smaller and smaller so the golf clubs could fit in the trunk. And that's what you're doing, because you're not going to take a lot of compute on board the individual. If Mercedes is eventually a customer, they're going to be able to put their golf clubs in the vehicle. Outside of the vehicle, what type of compute do you need to develop your neural net?
Yeah, outside the vehicle, that's a good question because I mean, Mercedes is working on the NVIDIA Orin today, and that compute will certainly not take up any boot room. In fact, if you go in our demo cars today that we operate, I'm pretty sure you'll be able to fit your golf clubs in the back of them. But for training, so that's the neat thing, right? Is that we train at extraordinary compute scale. That means that the neural network can be very efficient and effective and deployed with a lean amount of inference, edge compute for inference. But for training, yeah, it's extraordinary. It's a scale that we want to push scale that goes beyond some of the largest training runs today. It's not like training a language model where you can put all the data on the compute nodes, but we've got to deal with hundreds of petabytes of video. So we've been excited to be partnered with Microsoft for the last 4 or 5 years. And together we have ambition and are building out the infrastructure to make this possible. The high bandwidth video access, the incredible GPU architectures to be able to train this kind of thing at scale. This is the kind of infrastructure that we're building out to make these kind of models possible. But it's not just the training. You've got data curriculum selection, filtering. You've got simulation, evaluation. It's an entire fleet learning loop that we need to be able to spin incredibly quickly to improve the system. That's what we needed. It's interesting how you think most of the problem is onboard the car, but I'd argue 90% of it is the offboard challenge of developing the training and evaluation infrastructure to make this possible.
And how are you downloading the data from your test vehicles, say, or your vehicles that are in commercial operations with your partners?
We use a number of techniques. Some of the vehicles that we park in sites that have Wi-Fi or wired connections to them, we can just download it through those networks. Others, we have to upload over 4G, and then it's really important that you choose the right data. Many people struggle you have tons and tons of data, right? And struggle to find out the right scenarios to learn from. One of the neat things about our approach is it's very strong at understanding Like the latent representation we learn can really easily tell us what scenarios our data covers, where the edge cases are, and we can use these systems to extract that in an unlabeled way. We can just let our AI watch the thousands and thousands of hours of driving data and point out where those novel scenarios are. If you think about the safety case that's required for autonomous driving, certainly with an AB 2.0 approach, one of the core pillars is ensuring that our data covers the ODD, that we have the right scenarios to learn from. And this is where this can be really important, ensuring that our data models can ensure that our data covers the scenarios. Now, these scenarios might be analytically designed, like we look at traffic lights, roundabouts, 1-lane, 2-lane roads, et cetera, et cetera. Or we can actually just watch a ton of driving data and cluster it into different scenarios that come out naturally from the data. We can see the things that commonly occur. We can see how things relate to each other and use that to determine the scenarios themselves. So there's a bunch of interesting ideas there that machine learning makes possible, but ultimately you need to prove that your data gives you the right experience to train a safe and performant system.
How does that change when on the channel, or you go over to France where they're going to drive on the opposite side of the road in England, or if you go into America? How does that going to change your data collection strategy?
I mean, there's new things when you go to different countries, right? Like if you go to the US, you have 4-way stop signs. We don't have those in the UK. You have right turn at red, that rule, or I mean, even you drive on the right side of the road. So you need to learn these things. But there's a lot that's similar. Traffic lights generally work the same way. Pedestrians generally behave in a similar manner. And so the point being is that you don't need to learn everything from scratch. So I think we're going to see, as we go to new markets and new geographies, I think we're going to see an exponentially decreasing amount of data that we need to expand to a new area. Because the more experience you have, the less new stuff there is in the world. Now, the great thing about this is this makes it a really great model economically to be able to scale, because the enormous training required to get it to market in one market doesn't need to be replicated for each new place we go to. Or if you go to a new vehicle line or a new manufacturer, again, it doesn't require that extraordinary expense to adapt the system because it's so inherently adaptable, because it's learned concepts that generalize to different vehicles, use cases, or markets.
You can accelerate it. Bank of America estimates it's 5 to 7 times cheaper for the AI approach for autonomous vehicles. Yet, your certain competitors, Tesla's doing it, but yet other competitors are not. The data's there that the banks are validating your approach, the market's validating your approach. Why are more companies not undertaking this approach when it's a very robust road, it's a very safe road, and it's a scalable road, and most importantly, it's a road that can become a business at the end of the day where the economics make sense?
You don't have to convince me. We've been doing this for 6 or 7 years. But I think it's important to recognize that we didn't have all the proof points until the last couple of years, right? This has been a contrarian, scientific development for many years. And I think in the last year or two, we've seen the level of performance and the detailed thinking around a safety case that now makes us viable. And I think the market's starting to recognize that. It was interesting to see Tesla pivot to this approach last year. We're starting to see automotive manufacturers really push to work with this technology and get it into their vehicles quickly. I had an automotive CEO say to me a couple of weeks ago, wow, this is mind blowing. I want to change plans to get this in our vehicles quickly because of the potential it offers. And it actually can make a viable unit economic model for autonomy. I could speculate why more aren't working on it. I think when you've spent billions on another approach, this huge sunk cost problem, huge momentum problem, it's a different set of talent to build out an AI approach to a robotics approach, a different set of infrastructure. So the switching cost is not trivial. And I guess people have formed sort of religions around these approaches, right? And the jury's still not out. I think we still have a lot of interesting problems to solve from here to be able to get this to scale. But I feel convicted and confident that we've got the team that can pull this off.
Another thing, we're not going to get into the details, but you have world-class investors. Microsoft is an investor, and they're a long-term stable investor, and they do a really good job of scaling their automotive. And look at what Sasha's done with scaling Zor. He's going to find the next growth. There's no doubt about that. Perhaps you are the next growth element for them. You mentioned you're talking to a CEO and he wants to get your technology in their vehicle. What is the Wayve commercialization model?
Yeah, I think there's a few different models we're seeing now to be able to bring autonomy to scale. And of course, where we all want to be is to be able to see the benefits of L4, the improved safety, sustainability, and accessibility of transport at global scale. That's where we want to get to. So how do you get there? Well, one strategy is you constrain the problem down to a set domain. and you throw all the money you can at it to over-engineer the solution to be able to get it to work there. And we're seeing some solutions like that in Beijing or in San Francisco, where you have these retrofit robo-taxis. And the challenge from there is, I mean, it's really impressive. It's mind-blowing to go ride in one of those, but the challenge from there is to cost it down, optimize it, and figure out the manufacturing problem to get it to scale. And that's a very difficult and challenging journey. In particular, during that, these companies are running 1,000 or so vehicles, and the data diversity you get from running around a single city is fairly limited. I think, and what we're seeing as a better approach and what Wayve is taking is we want to get the software deployed quickly and broadly as a driver assistance system. And I mentioned that production vehicles today that are coming online have the sensing and compute, or many of the manufacturers that we're excited about have invested in the level of software-defined vehicles and the onboard embedded compute that is required to run an approach like ours. So we don't need to change any hardware or add on or retrofit anything. We can work with production vehicles today and have the neural network deployed. The advantage of this is that we can start to give consumers exposure to embodied AI. Rather than dropping in an L4 solution from day zero, we give them an exposure to a companion, co-pilot, driver assistance system, and it can learn over time and quickly develop to a point where it can become L4 and autonomous. The beauty is we get global and diverse data from this. We can train and validate the system to be provably safe. And of course, the business validation and revenue and build a more sustainable business to grow up in this way. And so I think that approach is an exciting one. And it's an exciting one because the automotive industry has made the bold step to move towards open compute platforms, move away from solutions like Mobileye that are closed products, and move to compute platforms like the NVIDIA Orin or Thor, Qualcomm chips, Renaissance chips, or whatever embedded system that you're working on. I think this is all very exciting for us and gives us that opportunity to get AI deployed into millions of vehicles soon.
Brilliant. Brilliant. I was reading a report from Tom Naran from RBC Capital Markets today on Tesla, and Mr. Naran does a really great job of breaking down the potential of FSD from an economic standpoint. And Mr. Naran put out a paper today estimating that FSD could generate over $18 billion a year in licensing revenue by 2030 if one OEM comes on board. It's a really interesting paper. So let's just hypothetically say you go into the licensing business, you're putting it in several global OEMs. It's a very profitable business. It's a very interesting business. Does that get deployed as an over-the-air update to the vehicle since you're working with the manufacturer, or how can that technology get into the vehicles that you do not have to update the hardware?
I think what excites me is about working with vehicles that have the necessary architecture to support an L4 deployment. So those that have redundant sensing, say camera radar or camera LiDAR or something like this, as well as redundant actuation, so that you can have a fail-safe braking system, for example, and a decent amount of embedded compute. That kind of platform is exciting because, yes, we can deploy as an L2 plus system. We've got the performance there today. But not only that, we can over there update it and improve the system, just like GPT-1, 2, 3, 4, and beyond is growing. Our system continues to get better over time with more compute and data. So as we improve and validate levels of safety in various operating domains, of course, we want to be able to over there update this and give these benefits to consumers as quickly as possible. I think that's the right model to be able to get the system out there quickly and grow it to that end state that we all dream of.
Do you feel that Tesla's FSD12, which for the record is getting really great reviews from Tesla fanatics, but also non-Tesla fanatics and banks are very bullish on it. Do you feel that that validates your approach?
I'd invite you to come ride in our system in London. It's pretty exciting to see, to sit in an end-to-end neural network approach and drive around in a busy urban environment. It doesn't get more complex than that. It is super challenging with dynamic road agents everywhere. And the beauty of an AV 2.0 approach is you see human-like behavior, you see complex and intelligent reasoning through some really challenging edge cases and intersections. I'm not surprised that people are inspired by AV 2.0. It is for sure the future.
What competitive advantages do you have testing in London? If you're going around Piccadilly Circle, it's a very difficult driving environment, to say the least. And there's other parts of London that are very congested and difficult driving. What advantages do you have?
London, yeah, it's pretty hard, right? It's one of the hardest in driving environments. It was designed for horse and carriages, and now we've gone and thrown millions of cars in the city. It's an interesting one, right? I think it forces us to build something that's scalable, forces us to build something that can deal with these kind of complexities. And it's been a great forcing function through development so far. I mean, in many ways, you want to start with the hardest thing first, because if you start with the easy problems and then find out later you can't solve the hard ones, then you're dead in the water. So that principle, I think, has helped us out so far. I'm really excited to be bringing this technology to other countries around the world, in the EU, the US, and beyond, maybe even my home country, New Zealand, one day soon. I think the things that we learn from the challenging streets of London will pay us well in those places.
When do we get to the moment when the king goes for a ride in the Wave car?
Well, the Prime Minister was going to come, I think, last year, but sadly, we were told that he only rides in cars with bulletproof glass, I think, like this. So I don't know if the king would have similar security requirements, but maybe we can automate his horse-drawn carriage one day.
There you go. I always thought about it with his mother, the Queen, for the Jubilee, have it automated, and that's the moment that autonomy goes mainstream. So perhaps it's the king or the current king or the next king, unsure, but we will have that moment at some point. Perhaps you do it on the grounds of Windsor. It's a safe, controlled environment. Who knows? When will Wave look to come to the U.S. to test, then potentially expand into commercial operations?
Yeah, watch that space. We have a flourishing office in the San Francisco Bay Area, and some growing vehicle operations there. So I'm really excited for our US expansion and continued growth.
You talk a lot about data, and I started working with some banks and analyzing data from the self-driving perspective. When does data become an asset class?
Yeah, I that is a really exciting question, and one that I think I would love to see more of a data market. I think there are some companies around the world that have extraordinary data assets, and the barrier to monetizing them is significant. You need to build and manage infrastructure and things like this, but there is so much extraordinary data around the world. And man, if we had millions of hours of data for driving and we were able to just feed it into our machine learning system, I think we'd solve this problem tomorrow. So I would love to see a marketplace like this. I'd love the Wave to help create it. I hope that the diverse OEMs that we partner with, we can create that kind of aggregated, crowdsourced data source that can enable safe and performant embodied AI systems. But I think we're going to start to see that soon. I think we're already seeing commercial relationships where you have exchange of value data as part of the value exchange. And certainly, I think with our partnerships, and it's a very important asset to recognize. But the last thing I'd say is that, look, I've had the chance to meet most OEMs around the world over the last year, and they vary greatly in their capabilities and the investments they've made, the maturity of their platform to take an AI solution, the investments they've made in a software-defined vehicle that can both get data off it as well as do over-the-air updates. These things are so important for the future, and some OEMs have mastered them and some are just scratching the surface. But it's also been interesting to see on the data front, the diversity and perspectives there. Some OEMs are actively collecting data from their consumer fleets. They have hundreds of vehicles in a development fleet that are also collecting data, and they know how to sort, organize, and store this level of data. That's amazing. These OEMs are in a position that are ready to win in the age of AI. And then some are starting to build that and have recognized this gap and have started to make those investments to grow these data assets. And look, we're excited to help the automotive industry grow these data assets, to help understand which data is important, because of course, ingesting hundreds of petabytes of data has extraordinary networking costs. And our model can help filter and understand this data and then ultimately exploit it to be able to provide the benefits of AI to their vehicles. I'm really excited to see the growth in this area. But yeah, great question.
Did you eventually get to the point where you license your model? You have your own version of Dojo, you have your own version of Azure, where you license that model to allow OEMs to train data or to use your data for training purposes?
I think it's important that we build a safety critical training loop. And it's also one that requires extraordinary amount of scale to be able to provide the level of performance that we need for safety. This is something that we're building out, like I was saying, in Microsoft Azure with our partner Microsoft. It's a pretty challenging task to be able to replicate that or pass that to a customer is a pretty challenging thing from a technical perspective. So I think it makes more sense for us to build and maintain the system and to flow data into it to be able to improve the performance of our AI. But having said that, we want to do this in collaboration with our partners. I think this is not just you provide a model and it's just a black box thing, but actually there are so many customizations you can do on it, whether a specific automotive partner wants to have a certain driving style, whether in different markets there are different behaviors. We talked about the four-way stop signs in the US, or maybe you want to drive with a conservative view, maybe you want to drive with a sporty or aggressive view. I don't know what various brands feel around their driving style. But all of these things are possible to customize and build feedback into the system. And we want to build a collaborative learning loop with our partners where it's transparent. They can see the model scorecard, the performance across the board of how our model performs against various different metrics. And then, of course, influence and change these to adapt to the specific behaviors and requirements that their brand has.
Why take a partnership approach? In my opinion, it's the right approach, but why take the partnership approach and not build your own vehicle?
One of the principles we've had from the very beginning is to partner with some of the most innovative companies and to be able to focus on our expertise. Some companies are looking to build out everything in the value chain, but that's hard, right? Like building a vehicle and bringing that to market. I'm in awe that everyone's done it. And I think probably pulling that off is equally a big challenge as building the AI. So I think it makes sense to partner there. I also think there's a much larger market. Sure, if we build our own vehicle, maybe we can get it to 1 million vehicles volume. But if you look at the diversity of vehicles that manufacturers around the world build, partnering there, I think that's just better. It's more scale. It can produce a better solution. And more importantly, it's faster because that expertise is already there. In general, this principle has served us well over the years because it's like, let's take cloud compute as well. We could build out our own dojo, our own data center, but by partnering with Microsoft, they've got extraordinary expertise, leverage of the scale they run and things like this. And it means that, again, our team can stay focused on the things that the market can't support and the unique things we can bring, namely building the AI.
In your opinion, what is the future of Wayve?
It's a really exciting question to contemplate. I think that if we cast our mind ahead 30 years, I think embodied AI is going to be the most transformative technology of our lifetimes. Being able to introduce intelligent machines that we can trust, we can delegate tasks to, that can automate things from domestic tasks at home to delivery or to personal transport. I think the embodied AI that Wayve is building is going to help pioneer and catalyze the age of autonomy, make these things possible, starting, of course, with autonomous driving. But I think we'll trust these embodied AI systems to do so much more. And I can't wait to make that happen.
They're going to change the world. And we do a lot of generative AI at home with images. And you see the images that they can create. A bear on a skateboard. My daughter thought it was the coolest thing in the world. And she made bookmarks for her class with flamingos. So it's starting that curiosity. And we're going to graduate a lot of really interesting engineers. And these children are going to go on to build something and build on top of what you're already building with Wayve. And we're really looking forward to seeing Wayve scale. Pitch, we'd love to welcome you to Florida. I know that the individuals and the governor listens. They'd love to welcome you here. Alex, as we look to wrap up this insightful conversation, what would you like our viewers and listeners to take away with them today?
Oh, thanks. Well, hey, look, I hope that some of what we've talked about can inspire a few things. One is ideas and investments that we can make as an industry, as a society to accelerate the growth, to see the benefits of AI, whether that's building data assets, whether that's ensuring that next generation vehicles can these AI deployed on them. I think this is such a huge opportunity. And it's going to take a collective effort on that front. I hope that this inspires that. And then secondly, I think when it comes to the product, the driving experience of what you can do with embodied AI, we didn't talk too much about it, but a few quick points there. We can build an AI system that can, as we're talking about, drive in a general sense, one that you can trust, that can understand and explain its actions, one that can build a relationship with you and make sure that the tasks that are doing match your preferences and are done so in a way that conforms to the expectations you have. All of these kind of possibilities are quite different from the lane keep assist experience we have today, or the robo-taxi experience where it's driving a set route where you don't have no control over the driving style, right? And I hope that folks might be able to take some inspiration from what embodied AI makes possible, and I look forward to the day when we can launch it to the world.
Wayve is building the future. Go catch the wave. The future is bright. The future is autonomous. The future is Wayve. Alex, thank you so much for coming on the road to autonomy today.
Oh, thank you. This has been a fun conversation. Cheers.